So I take this opportunity to welcome you people to this class for computer networks. We are going to use Cisco Packet Tracer, and it is a simulator, as the name suggests. It simulates network devices and its environment. So there are different protocols in Packet Tracer that are coded to work and behave in the same way as they would in a real hardware. These protocols include, for example, if you are working with the technology of local area networks, you will include things like the Ethernet. There are different types of Ethernet bands that you can work with. If you are working with switches, there are configuration protocols that are normally being taken care of with switching protocols like virtual local area network, sometimes called VLANs, multi-layer switchings, Ethernet channels. You can work with the TCP/IP. I presume that you had done TCP/IP protocol in computer networks. And this TCP/IP protocols involves configuration of different protocols such as the HTTP, HTTPS, DHCP version 6, especially when you are working with IP version 6, Telnet, SSH, DNS, TCP, UDP, IP version 4, IP version 6, ICMP version 6, ARP, IP version 6, FTP, SMTP, POP3, and VoIP, which is basically sometimes referenced as H32.3. We have routing protocols that can also be done here. Routing protocols such as static, default, RIP version 1, RIP version 2, single area OSPF, multi-area OSPF, inter-VLAN routing, and redistribution. Similarly, if suppose you decide that you want to do a simulation of wide area networks, you can do the HDLC, SLARP, triple P and free relay. You can also do security in terms of looking at IP security, system logs. You can decide that you want to do SSH. You can do other miscellaneous configurations such as things to do with ACL and configuration of NAT. So basically, I presume that you had installed Cisco Packet Tracer for if you are working with Windows, like the way today I'm working with the Windows operating system. And also, if you are working with Linux, you must have found the Linux version for the Windows, for the Linux, I mean. So basically, when you look at the interface of this application, there are areas that are very much common when you look at each and every application that has been developed. First of all, at the top here, we have the menu bar, and this menu bar helps you in giving you directions on whatever you are supposed to do in this application. The next thing we have is the toolbar, which has basically the graphical representation of the different commands that are supposed to be used in this application. The next one is about the logical or physical workspace tab, which is represented here. So you can decide I want to work with the physical location or I want to do with the logical. The physical location and at least enables you to be able to at least look at a given area that you want to work with within your physical environment. Whether you want to work with a city or you want to work with any type of physical environment that you want to simulate your network from. Then we have the workspace, which is this area here. Then the next thing, we have the common toolbars that are being used, especially the ones that are also used in networks as representation. We will look at them, for example, the ones that are represented here for simulation and the rest. Then we have the real-time simulation tabs down here. And then we have network components that are represented here. These are the different network components from routers to switches to different IoT devices that can be used in the network. Then the next thing we have is the user created packet box that is a highly customized packet to test their topology from an area. This area is what we are calling the user created packet box. You can be able to at least simulate and look at how the different packets are moving from a networking area. Now, basically, when you want to create a simple topology in a network, we look at connection from the different end devices. So, for example, when you start with the generic devices that we have here, we have end devices like, for example, the PC. I can decide that I want the PC here. When you get to see the PC, and then I can decide that I want to another end device, which is a laptop here. These devices are the end devices, especially in the network that you do normally use on a daily basis. Now, these connections do normally take place, especially when you are using copper straight through cables, crossover or straight through. What is the difference between a crossover and a straight through cable? Anybody with an answer? What is the difference between a crossover and a straight through cable? Hmm? What is the difference? Now, the copper straight through cable is normally being used, especially in the connection of different devices, especially if you are connecting a switch and an end device like a laptop here, or you are connecting a router and a switch, or you are connecting any other devices that are different within a networking protocol. But if you are connecting same devices that are almost devices that are the same, especially if I'm connecting, for example, PC and PC here, what will happen is that I will always connect using a crossover cable. A crossover cable is used in computer networks, especially when you are connecting same devices. So, for example, if I go to the connections here and pick a cable and connect here and connect with this one, the cable that has been used here in the connection is a crossover cable. And from here, I can do different configurations that I might want to this. The Cisco Packet Tracer enables you to be able to at least enable you to be at least able to simulate, be able to do configurations, not like you can be having the devices physically. So you can be able to at least do a configuration. From these devices that you can see here, I have PC0 and PC1, and I have a laptop here. I can be able to connect these devices and be able to simulate the different protocols that are working, that are supposed to work in these devices. For example, if I click here, all of you, I hope you can be able to at least see that window that is presented here. This window represents the graphical representation of configuration of this device. We have the physical configuration with the different host materials. We will look at what this means. We have the configuration here in terms of fast Ethernet, especially that is the concentration here, where you do normally connect your devices, especially when you are using the Ethernet cable. Then we have the desktop here, which represents ways in which you can be able to at least test your network, especially if, for example, if you decide I want to use the command prompt to test if the ping command can be able to be established from the different devices that are available. Then we have the programming environment and the attribute environment for the this device. So the main concentration here is basically on the fast Ethernet. And here at the fast Ethernet, you can see that this device, the fast Ethernet has been placed on, and IP configurations here are established. For example, we have DHCP, which is the dynamic host configuration protocol, and then we have the static protocol. What is the difference between DHCP and static protocol? Anybody? Anybody with an answer? Hey, you people are in this class.
I can answer.
Okay.
As a static protocol,
Yes.
the address that it's like a fixed address manually assigned to a device
Uh-huh.
that changes.
Okay.
On the flip side, the DHCP protocol is on that automatically assigns IP addresses to devices on a network.
Thank you. And especially the DHCP is normally got from the router. The reason why you do normally have the Wi-Fi in campus, especially when you are connecting your device, is as a result of the router being able to give you an IP protocol that you are using, especially in accessing the internet. The router is assigning you an IP address through the DHCP protocol. You do not configure it manually the way it is supposed to be done. Like, for example, here in this device, if I decide here, as per now, it is on static protocol. If I decide here I want to configure the class A, for example, the class A network protocol. Like, for example, if I decide to use 10.1.1.1 here, you will find that I've assigned a class A protocol to this, a class A IP address to this device. This is manually assigned IP address that is being got, especially from the configurations that you are doing in a network. If you suppose you have decided that you are going to go the manual way, you will always go through each and every device and configure an IP address. If I could decide that I'm going to configure an IP address also on this device on static, let's say, for example, on this one now, I'm going to start at 10.1.1.2. Then you find that not here, cut at the first Ethernet. Yes, then you find that this device is now at IP address .1.2. The other one was .1.1. And from here, you can be able to at least do a ping and find whether your device at PC1 is able to communicate with the device at PC0. For you to do a ping in Parket Tracer, you have to be very much aware of the IP address of PC0. PC0 here, for example, I go to the command prompt and ping the IP address of PC1. PC1 here was represented by 10.1.1.1. And you find that that reply that I am getting shows that there is a communication between PC1 and PC0. Let us try and rename them so that at least in terms of IP address, so that you can be able to identify them very much easily. So that one we have named as 10.1.1. This one we have named at 10.1.1.2. That is the IP address that we have used at this device. So we are using here the crossover cable to be able to at least connect to these devices so that they can be able to communicate more easily. Now, when I decide that I want to connect these devices with a straight-through cable, which is now involving connecting different devices. For example, if I decide to involve a switch, let me pick a switch here. For you to pick a switch, you go to the networking devices and you will be able to pick, let us work with switch 2690, which is having all the representation here. By the way, this graphical representation here shows you that you can decide that I want to power on or power off this device the way it is supposed to be. This one also enables you to be able to change different interfaces. More so, for example, if I want to change these different interfaces that are existing here, and I want to make this device to be able to connect to the wireless device, then probably I will be able to change at this point here. So this interfaces enables you to be able to, it represents the normal interface that when you are working with, for example, a desktop, you are able to see this, especially this one here. So you are able to see the first Ethernet where you would normally insert your cables in these devices. When you have, for example, a switch here, you are able to at least see the different connections that are available in this switch. So when I want to do a copper straight through cable, if you look at this connection that is represented like this one here, it shows you the different connections. When you place it here, it will automatically pick whatever you are supposed to use in connection. This one is the console cable. This one is the copper straight through cable. This is the copper straight over cable. This is the fiber cable. This is a phone cable. This is coaxial cable. This is the serial DCE cable, serial DTE cable, the octal cable, the IoT, and there are several of them that are represented here. This is the USB cable. And on the networking devices here, we have this one are all different types of routers. We have these different types of switches. We have these different types of hubs. If suppose you've decided that you want to use a hub, we have these different types of connecting devices, especially those that are working in the home. We have even cell towers represented here. Sometimes we call them repeaters in computer networks. We have home router, in which we are going to use home router and look at how does a home router work, especially those ones that you are using in your homes in connecting different devices within the network. Now, for example, you are in the house and you are connected to a Wi-Fi device or you are connected through the Ethernet. How is this connection able to function very much efficiently so that you can be able to connect to the internet? Then we have the representation here of the different firewalls. If suppose you want to use firewall 5506 or firewall 5505, the cloud representation is also here. Then on the end devices, we have the connections, PC, laptops, we have the servers, we have this one is called Meraki server, computer network controller, we have the printer here, we have the IP phone here, VoIP devices, the phone is here. If you are connecting to a TV, you are connecting to a tablet, you are connecting to a smartphone, you are connecting to a generic wireless device, you are connecting. There are so many devices here. And in terms of security, you can also have a sniffer within the network. So if suppose you wanted to test security on how sniffing do normally take place. Then the next component is the IoT. The IoT devices here represents different materials that are representing the Internet of Things. If suppose you want to simulate the connections of the Internet of Things within a networked environment, then you are able to use these different boards. These boards are represented here so that at least you can be able to use them. So if you are interested in connecting these boards, you can be able to at least simulate an IoT environment so that you can be able to connect very much easily. Then we have other devices that are also here that you can use in the connections. I've talked about the different cables and the different structures that you can use in the connection for physical device. Then there are miscellaneous connections, and that I've talked about if you are connecting to a remote networking environment. So basically, Packet Tracer has been packed with so many devices or so many simulations that a person can do within a networked environment, so that at least you can see the before you go on a physical device and be able to do breaking, or you can be able to at least mess up with the device. It is sometimes always good to at least do a simulation on how you intend to do your connection. Map the different types of topologies that you are taught in a network so that you can be able to do the connection very much easily. So let me remove this this copper straight through cable and be able to connect this switch here. And to some extent also I will also try as much as possible to involve a router. And inside this router we are going to use which one do I pick? Let us pick router 1841, which is also enabling you to be able to connect very much easily. So if you are connecting to a router, this one means that now we are going to use a copper straight through cable that is moving from fast Ethernet 01, fast Ethernet 01, or you can decide you want to connect it to the gigabyte 01. So fast Ethernet 01, and I'm connecting to fast Ethernet 00 on the router here. Then from here, I can be able, let me try as much as possible, to remove this. So that I can be able to use the copper straight through cable. So I will connect the copper straight through cable here at fast Ethernet 0 and here at fast Ethernet 2. Then I have here at fast Ethernet 3. Then I have here at fast Ethernet 0. So this one automatically now tells you that we have changed the structure of our network. We have our laptop here. Let us also connect our laptop. Our laptop is having the Ethernet. So we will also have our laptop connection at fast Ethernet 0, and this one is at fast Ethernet 04. So whenever you are connecting such kind of devices and you've connected them within a network, you can see that the representation, the greenish representation here shows you that those ports have become active and the connection can be seen through the switch. So it shows you when you even look at it from this point. Let me do a search. We look at it from this point here. It will show you that the first Ethernet is up. You can see there is a port there, and the link and the IP address is up, and this one is also up. There is the connection that is coming from the router, and the reason why this one is still in red is because the router connection has not been activated. I have not placed the first Ethernet 0, which is still down. The representation there shows you that the first Ethernet in the router is still down. So for me to place it up, I will click on the router and go to the configuration and go to fast Ethernet 0, and here turn it on. Whenever you turn it on, you can see that in the configurations of the router, you can either decide to use this graphical user interface, especially when you are using Cisco Packet Tracer, but it is not a guarantee that you are not going to connect to a router and you are going to find this graphical user interface. Most of them come with command line driven interface, and the command line driven interface is this one here. We will look at how to use the command line driven, especially when you are doing different connections. So when I place this on and I do I close it, you can see that I'm able to at least find I'm able to at least now make the connection through the switch becomes on to be on. Now, basically, when you are connecting, especially when you're using static routing, and I'm going to use static routing here. When you are using static routing at this point here, basically, at the first Ethernet 0 here, we normally configure the first IP address of the router at as IP dot one. Basically, the router do normally have the first IP address. So we will have, for example, 10.1.1.1, which is represented there. And then these other devices are now going to pick like now the IP address. This is going to pick like now the IP address 3. And we had picked that IP address as 10.1.1.3, which is now represented here. So whenever we are starting the connection, we can see that connection normally involves you being able to configure static routing of these devices at IP address 10.1.1.1 at the router, and then 10.1.1.2 at the different end devices within the connection that you are doing. So we can have our laptop here, rename the laptop as 10.1.1.4, and we are going to have the gateway that it is using is 10.0.1.1, because that is the name of the router. At first Ethernet, we are going to pick this copy at first Ethernet, that is the IP address that we are going to give it. So we will pick also configurations. We have not configured the it's called what? The global gateway. The global gateway is the IP of the router, so that at least they are able to communicate. So the IP of the router is 10.1.1.1. That is the IP of the router. I'll configure it on all the devices. The default gateway here is .1. Then the first Ethernet is at 2. So we will have the names as represented there. So normally this is what is now called static routing. You are configuring manually in all devices, especially when you are doing your configuration. You have to know the IP address that you gave at the router. You have to know the IP address that you are giving each and every device. It means that when you are doing configuration, you have to at least go through each and every device to find the connection. Normally the router, if you go at the router do normally have the physical representation. I had not shown you that. And the physical representation of this router 18 41 is represented in this diagram here. So when you zoom, you can be able to see the different connections that are available within this device. So this router here can be able to at least now communicate with these devices. For example, now if I ping here the address of the router, I ping 10.1.1.1, you can see that I'm able to find the communication with the router, which is at 10.1.1.1. This is where our connection is now taking place. Now, this is when you are doing, for example, static routing in devices. What happens now, for example, if you are doing the DHCP, which is the dynamic host configuration protocol, the way you do normally get IP addresses from your devices that you do normally use in the house. So let's take, for example, I have here we are going to use the router, which is finding the home router that you do normally use in houses. And let me have, for example, the end devices that are available here. I have this end device, PC2, I have PC3, and I'm going to pick a laptop. I'm going to pick here a phone, and I'm going to pick here a tablet. So whenever I pick, tablets do normally use Wi-Fi. You can see that the connection is happening automatically within these devices. I can decide now I want to pick a switch. Let me pick a switch 2660 for me to be able to connect these devices from the router. Like for example, when you have a switch in the house, so I'll have a copper straight through cable here and be able to connect at gigabyte Ethernet 1 and connect here at fast Ethernet 01. Then connect this at fast Ethernet 0, connect this at fast Ethernet 02, connect this at fast Ethernet 03, connect with fast Ethernet 0. So this one I have a connection that especially you normally have in your houses, the one that you do normally work with on a daily basis. Now I want to configure my laptop here to be able to at least connect to the Wi-Fi. In Cisco Packet Tracer, when you are connecting to a Wi-Fi, enabling a laptop to be able to be a Wi-Fi device, you are able to at least see the physical representation here. This is now the device that we are talking about. So I'm going to remove this. First of all, I must switch it off. This is the button for switching it off. So when I switch it off, I remove the cable, the fast Ethernet cable, and replace with the one for wireless connection, and then switch it on. So whenever I switch it on, it will be able to pick up the Wi-Fi configuration. So once it has picked on the Wi-Fi configuration, all the devices within this network has been configured with an IP address. You can see from the DHCP configuration, we have the IP address of the gateway as 01. The wireless connection is being given an IP address here as 1002. As 102. This one now we are using class C IP address, which is the 192.168.0.102. The phone has also been given an IP address. When I look at configuration, you can see it is at 01. The wireless device is at 100, which is the IP address. This is the DHCP, the Dynamic Host Configuration Protocol. If suppose we connected our Wi-Fi using a password, we could have been configuring the password here to enable the connection. We have our tablet here represented. If you look at it, we have the tablet representation here. And look at the DHCP, we have 01. We have the wireless connection here, which is enabling the connection to be able to take place. Given an IP address at 101. So let's, for example, here at the PC, I want to use the names of the IP address that they have been given, so that I can be able to at least ping through these devices, so that we can see the communication the way it is taking place. So we have this one being given an IP address at 100, 192.168.0.100. That is the name. The laptop here has been given 102. So we have 192.168.0.102 for the DHCP. So this is the connection. So for example, if I go to the laptop and go to the command prompt and I want to ping the IP address of the tablet, so I can be able to ping. Ping command enables you to test the loop, the connections, if there is a communications between the devices within the network. So I will use the ping and I will enter the IP address of the tablet, 192.168. Dot 168.0.101. So you can see from the reply here, I'm getting full communication. There is no packet that is lost. This one shows that there is a communication between the laptop and the tablet. How these IP addresses are being got is as a result of the fact that we are connecting the DHCP to be able to assign IP address like the way you do, especially when you are connecting your devices within a Wi-Fi network or within your home network that you have set up. So if I go to PC2 and PC3 and be able to ping the IP address, for example, for the tablet, we want to see whatever happens. Let's wait and see. Much like the representation of whatever happens, especially if the network is not responding. Why do you think that the tablet is unable to communicate with the PC? Anybody with an answer? Hmm? Anybody? Okay, Ken. Ken is raising his hands and then suddenly is out of the meeting again. Okay.
Uh, I think uh, I think because there's no direct communication between the tablet and the PC.
Yeah. Okay. Anybody with another different angle of looking at this? Anybody with a different angle of looking at this? Now, what happens here is if you look at the physical configuration, is that the PC is still at having the static way of entering an IP address. I have not changed the configuration protocol to be in the DHCP. Now let me do that. When I change this one to be in DHCP, now you see it is able to pick the router and it is able to get an IP address. Now when I do the ping again, are you seeing whatever has happened? Are you seeing the difference? Yeah? So whatever has happened is that now when I enable this PC to have the configurations of the DHCP where the router is the one that is giving it protocols, then you find that the connection now, there is a communication that is happening, especially from the device. It is able to at least see the tablet within the network. Same thing I will do to the other PC here, enable the DHCP so that it can be able to configure the network automatically. And when I do, for example, now I do that ping command, I want to look at the IP of the phone. For example, I want to ping 192.168.0.100. Then you can see that there is a connection that takes place. It means that in each and every networking environment that you are working with, especially in your home environment, you will find that the DHCP is the common protocol that you do normally use. When you look at the router configuration protocol here, this is the router. This is the common router that you have in your houses. When you look at the back, you can be able to see the connections for the internet, the connections for the different fast Ethernet 1, 2, 3, and 4 that is represented. Then when you look at the configuration, we have the configuration for the internet, for the local area network, for the internet. If you have, for example, here I'm choosing DHCP configuration, and that is what we are using. When you look at the graphical user interface, this is the common one. Whenever you log into the router, home router, this is the common thing that you do normally work with. You find yourself having this auto configuration of the DHCP protocol, where the first IP address that you are assigning here is 192.168.0.1 using, for example, the class C network IP address, and you give the starting IP address to be at 100. That is why we have 101, 102, 103, and the maximum number of people that can connect to that router is 50. So I can go to a home router and restrict that the number of people that can all be able to connect to my home router are only 3 people. Well, after 3 people, more than 3 people, it cannot be able to connect. This is the wireless connection where you do normally do the configuration of the different passwords that are available. Depending on the protocol that you want to use, you can be able to at least define whatever you want to use in the connections at this point here. Then we have the security. where you define the different, if suppose you are connecting to a firewall. On the wireless configuration here, we have auto configuration, um, other network bands. If suppose you want to define the network bands, we have the wireless security. You can see when I click on wireless security here, it is disabled. When I enable it, for example, YPA, we always use YPA2, then it shows me to enter the password if suppose I want to configure the password. If I configure the password, for example, here at 1, 2, 3, 4, 5, 6, 7, 8, then you find that that one becomes our password for this device. I save changes, and whenever I save such kind of changes, the encryption are now also here. You can choose the type of encryption that you want. The basic configuration that we are using at this point here is the default, and the configuration that we are picking here are, for example, this network connection. So this now allows you to be able to enter the password. If you suppose you want to enable guest profile for people to be able to connect your network as guests, you can be able to filter different MAC addresses that are available. Let me first of all change this one to back to disabled and save settings. If I want to check, for example, the different MAC address of different devices, I want to go to the tablet and pick the MAC address of this device so that at least I can be able to at least use that MAC address so that I can be able to configure it so that this device is the one that can be able to connect to my network. Let me see if I can get the MAC address. If I go to the desktop, I go to command prompt and use ipconfig. I can be able to get that it is connected to the wireless IP address. This is now the MAC address of this device. If suppose I wanted to do my configuration using the MAC address. So this MAC address enables me to be able to at least, this is what I will enter at the configuration of this wireless client list. So when I enter this MAC address here, no, this is not the MAC address. Let me see. This is IP version 6 address. Let me see. Let me see if I can get the MAC address. Yeah, sometimes called the physical address. I don't know whether it was represented here. Sometimes called the physical address. This one is the address that we are talking about. So when you look at the physical address is represented here, even with this wireless connection that you are supposed to use, especially when you want to connect to these devices in your network very much easily. This provides you, if you go enter, provides you with more information, especially if you do ipconfig.all, to be able to at least find more details on the different devices that you are using within the network. So when I want to restrict the connections of different devices, I can have my Wi-Fi connection, but at the same time filter them in terms of MAC address, depending on the device that I've allowed to be able to connect. So when I enable this, I can be able to put these connections so that this device can be able to connect or be able not to connect within that network. So this is DHCP configuration when you are working with the normal network that you do normally do. Now, there is something that I have not shown you within this device. Normally, when you have these devices connected, you can be able to at least let me adjust them at this point here. And let's see the other thing that is going to happen. Now, within these devices, this is the normal connections. We have the simulation. Simulation here enables you to be able to at least see the connections of whatever is happening at real time, how packets are being sent within these devices. For example, when I play the simulation and let us watch whatever happens, the different types of protocols are represented here and the connection, the way they are being done. Let me adjust so that it goes faster. So this is how you can be able to monitor your packets when you connect to a networking environment and be able to monitor them very much efficiently within a networked environment. This enables you to be able to at least work with your devices very much easily. If suppose I click on any of these packets that have been sent, especially from our home wireless router, you can be able to see the representation here. The representation here in terms of the layers of the OC model. We talk of layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. This is now the representation and outbound representation of how the communication is taking place within a networking environment. This is the OC model representation of the connections of the different devices within that network. When you look at this, the connection here is at first Ethernet 0, the connection here is at layer 2. We have not gone up to the application layer within the OC model. So somehow you can be able to at least be able to see the different protocols that you are working with within your network if you are doing a simulation and want to do more connection in your network device. Any question up to there? Carlos, people when they are late in my class, they don't come in. Any other question? Ken?
With this current setup,
Yes.
can PC can PC 10.1.1.2
Yes.
communicate with PC 2?
It can't communicate.
Okay.
Now for PC1, for PC 10.1.1.2 to communicate with this one, this is now where we have now comes up with router communication. Like when you are browsing the internet, you are normally in the house and communicating to your router. Your router takes the packet that you are sending to another destination router so that it can be received by the destination IP address, especially when you are doing, for example, google.com. When you are doing google.com, there is a representation of each and every network, each and every domain is represented by an IP address. There is, I think there is an article that I wrote about that. Let me look for it and give you through the chat and see whatever, and you can have a little bit to read it. On whatever happens, especially when you write google.com and the translations that take place, so that at least you can be able to get to see whatever normally happens, the conversions that do normally go through you do normally go through, especially when you are uh, 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 when you are connecting to your device through a network. So I posted a link. That link looks at answering the web infrastructure questions on whatever happens, especially when you write google.com into your web browser and the conversions that take place. Is a little bit of descriptions of whatever technologies that do normally take place. So we can say that within this communication that is taking place here, within this communication that is taking place here, we can represent this one as, for example, let me stop the simulation. We can represent this one as we can represent the whole of this as the first LAN, and represent represent this one as the second LAN. So whenever you are communicating with your devices, you are in a local area network, and that local area network enables you to be able to communicate very much easily within a networked environment. So this is the first LAN. This is the second local area network. And this local area network enables you to be able to communicate with the different networking devices. Anybody with a question? So for me to be able to communicate from this point here to this other network, I will have maybe another router that will communicate with this one, and the other another router that will communicate with this one. So that connection will now connect a local area network with another local area network to form now a wide area network. Anybody with a question? Anyone with a question? I know most of you still not are not getting whatever is happening here. I'm going to send. Ken, can you help me with your email through the chat so that I can be able to now communicate through an email and send for you the different reference material that you can use, especially in Packet Tracer, and one of the assignments so that at least you can try Packet Tracer in your connection. So you have to go and read read about connections with Packet Tracer, and after reading the connections with Packet Tracer, then there is one assignment that I'm going to send through the email for Ken, so that at least you can be able to try it out tomorrow. Then we see how on Wednesday we can be able to at least see those configurations the way they take place within a networked environment. Question, Dixon?
Cool.
Dixon?
My question.
Dixon, I'm not getting you well.
Are we done with the introduction to Python and
On introduction to Python, I'd introduce you to the basics. You can go through the basics on Python programming. That is all that I wanted us to do, so that at least when we start our project on Django, you at least have the basic foundation on Python programming.